Okay, today we're going to talk a little bit about investments involving regular payments. Um, so we've talked about investing up to this point in compound interest, but all of that to this point has involved just making one lump sum investment at the start of a term and then letting interest go and do its thing. What's more common is for people to make sort of regular investments into, or regular payments into an investment. Save so much every month, say for instance, into an account. Um, so we'll talk a little bit about some of the math behind that and how we can work out problems dealing with that type of investment. Um, First, I'm going to take a look at example one on page 47. I'm going to dive right in. Although I'm not going to go through the entirety of this example, I really just want to cite it as something to talk about for a moment. Um, this basically describes someone making regular deposits of $500 into a savings account at the end of every 6 month period. Um, the account earns 3.8% interest compounded semi annually. How much will they have at the end of 5 years? So this is regular payments of $500 into an account that pays 3 point cent earns, I should say, that earns 3.8% interest compounded, that's what that word is, semi-annually. The payments are made every 6 months. Focus. All right, so in this particular case, you can't just use the compound interest formula on its own because not every $500 chunk is going to go through the same investment term. So the first $500 gets put in. Oh, should put that part of it in. Determine the value after 5 years. But a lot of focus. Okay, so the first $500 that you put in at the end of 6 months, it's going to collect interest for 4.5 months. The next 500, or 4.5 years, I should say, the next $500 you put in will only generate interest for 4 years. The next $500 you put in would only generate interest for 3.5 years, and so on. To work this out manually, or to work this out by hand, you would need to use the compound interest formula on each $500 deposit. And so even for this simple sort of situation, that would be 9 different compound interest equations that you'd need to run, 10 different compound interest equations that you'd need to run through. That's a lot more work than we want to do. So I'm going to show you how you can do this with the solver, basically using the regular payment option on there. So what I've got in this case, if I look at the old solver, which hopefully won't get too bright for us, that's really bright. That did not help. That's better. Okay. So if I go back into apps, under finance, under the TVM solver. So my different options. N. Since I'm doing things semi-annually for 5 years, that's going to be 5 times 2, or 10 for my N value. The account's earning 3.8% interest. no money is put in to start, but regular payments of $500 are being made. So what that looks like is, while that's going on, you are effectively losing $500 every 6 months to go into this account. Your future value is what you're interested in, and you're putting in 2 payments per year, and you're getting the interest compounded twice per year. Now you can start to see where these two things might end up being different sometimes. Let's say you were putting in money monthly, but the interest was only compounding semi-annually. Then you'd have had 12 and 2 in those 2 cases. But for now, we're making 2 payments per year, and interest is compounding twice per year. If I then solve for future value, that ends up being worth $5,731.94. And that is much easier than using the compound interest formula, not 10 different times. The future value is $5,731.94. So I'm going to work through a couple more examples a little bit more definitively than that, but that's just to show you how you can use the solver to work these out. So, going along one line, we'll look at example 2. That was what that was supposed to be. Example 2 from page 49. Adam made a $200 payment at the end of each year into an investment that earned 5% compounded annually. Blake made a single investment at 5% compounded annually. At the end of 5 years, their future values were equal. What was that future value? What amount did Blake invest at the start of his time, and who earned more interest? So for these sorts of questions, when you're dealing with 2 different setups, it's good to break them up. So I've got Adam's setup, and I've got Blake's setup. Now in each case, it's a 5-year investment that's being compounded annually. So my end value is going to be 5 for each case. They earn the same amount of interest, which is also 5%. That's a little bit too much the same for my liking, but that's what we got to work with. All right, present value. Adam does not put anything in to start with. Blake's present value, we don't know. That's part of what we're trying to find out. Adam is putting in regular payments of $200. Blake only made one lump sum investment, so he's not making any regular payments. Future value is what we're not sure about in this case, but they will be the same for each person. Adam is making 1 payment per year. Now, it doesn't really matter what you put in here for Blake because he's not making any regular payments, but we might as well just keep it the same. And in each case, the interest is being compounded annually as well. Now, I don't have enough information to work out Blake's info yet, but I do have enough to work out Adam's. Equals 5, I equals 5, present value is 0, regular payments of $200 being paid once a year. At the end of 5 years, Adam will have $1,105.13. Now we were also told that Blake was going to have the same amount, so we can just set that equal there. And then that gives us enough to figure out what Blake first invested. Focus. So no regular payments, the same future value, same pay period and compounding period. Then I solve for present value. And I get negative 865.90. So then we're asked a series of questions. A asks, what is their future value? Where's my focus? I'm on focus. Oh, this thing. Thanks for that. Okay. So, what was their future value? Well, we know that's $1,105.13. Really? This thing's great. Okay. B. What principal amount did Blake invest? Well, we know that as well. That's the $865.90. You don't need to include the negative there. That negative is just showing that that was money he paid out at the start of this investment. And see who earned more interest and why. We'll start with who earned more interest. That's going to be a little bit of a calculation. Adam invested $200 5 times. Total investment $1,000. The future value was $1,105.13. Therefore, his interest earned was $105.13. Blake invested $865.90 once at the first. His future value, $1105.13. If I take the difference, I would get $239.23. Pardon me. So, Blake earned more interest. Now the question is why? Well, Blake's $865.90 all earned 5% interest over the entire 5-year term. Adam's money did not earn all that the entire time. In fact, his first $200 would have only earned, since it went in at the end of the year, would have only earned 4 years of interest. His second $200 would have only earned 3 years of interest, and so on. So overall, Blake has more time to earn money on everything he put in. Blake's upfront investment allowed more interest to accrue, when you use a big fancy word. It's not that big, I suppose, but it's kind of fancy. So, if you've got the money to invest up front, that means you'll earn more from it, but a lot of times people don't have a big lump sum to invest, so they will put away a little bit at a time to build up an investment. Another example. This is example 3 off page 51. Where we're told Jeremiah deposits $750 into an investment account at the end of every 3 months, or quarterly. Interest is compounded quarterly. The term is 3 years, and the future value is $10,059.07. What annual rate of interest does Jeremiah's investment earn? So now we're just dealing with variations on this theme. So we identify what we can identify. If I go in the order the solver goes, since my term is 3 years and interest is compounded quarterly, and pay periods are quarterly, and that's kind of the important thing here, n will equal 12. The interest rate is what we're trying to figure out. Good old autofocus. The present value, that's the initial investment amount, and there is no initial investment. But we're making regular payments of $750. Oh. That better? Thank you. To get a future value of $10,059.07. There are 4 pay periods in a year if we're doing this every 3 months. And there are 4 compounding periods in a year if we're doing this quarterly. So then, so bright, I fill in 12, interest what I'm trying to figure out, no initial investment, but a regular payment of $750 to get to a total of $10,059.07 with quarterly compounding pay periods. So our interest rate, might as well call that 8%. So Jeremiah's annual interest is 8%. And onward, example 4. And example 4 kind of shows a bit more of what would happen if you were planning for something, if you're making investments to plan for a certain outcome. In example 4, ooh, autofocus. That's great, thank you. Thanks, autofocus. Real helpful. This is going great. Stay. Okay. In example 4, Celia wants to have $300,000 in 20 years so that she can retire. Celia has found a trust account that earns a fixed rate of 10.8% compounded annually. And we're asked, what regular payments must Celia make at the end of each year to meet her goal, and how much interest will she earn over the 20 years? So n is simple in this case. The term is 20 years and there's only 1 payment per year. So n is just 20. Our interest rate is 10.8%, which is a pretty sweet deal for a fixed investment for that long. Nothing in upfront. We're trying to figure out what the regular payment has to be. We want to end up with $300,000, making 1 payment per year and compounding once per year. So we fill that all in. 20, 10.8. No initial. We don't know what the payment is. We know we want $300,000. Who wouldn't? And then we can solve for what regular investment you've got to make that happen. And it is $4,781.09. So the A part of our question we could just Celia must invest $4,781.09 every year to end up with $300,000. Now the B part of this asks how much interest she's earned, and it's going to end up being a fair chunk. So Celia invested $4,781.09 every year for 20 years. So our total investment, $4,781.09 times 20, $95,621.80. Celia got $300,000. So she earned the difference between the two, or $204,378.20, I think. Yay. $204,378.20 in interest, which is a lot of money to get in interest. And the one thing that's a little unrealistic about this is finding some place to give you a regular 10.8% on your investment for 20 years. That's a pretty good deal. If you find that anywhere, I suggest you take it. Alright, I'm going to go through one more example, and then I will stop at that. This is example 5, page 53. And on Luis's 20th birthday, he started making regular $1,000 payments into an investment account at the end of every 6 months. He wants to save for a down payment on a home. His investment earns 3.5% compounded semi-annually. At what age will he have more than $18,000? Alright, so time is what we're interested in. So in this case, N is what I'm going to try to figure out. He's getting 3.5% compounded annually, or sorry, semi-annually. He's made no initial investment, but he's making regular payments of $1,000. We want to find out when he ends up with $18,000. Since he's making payments every 6 months, then he's making 2 payments per year. And since the investment is compounded semi-annually, there are 2 compounding periods per year. So we'll solve that for N. Into our apps, finance, future value, TMZ solver. I don't know my N value. I'll put in 3.5 for my interest rate. No initial payment, or no initial investment, but regular payments of $1,000 into the investment. When does he end up at $18,000 with 2 pay periods a year, 2 compounding periods a year? I solve for N, and it's worth stressing what N represents in this case. So N represents the number of pay periods that have gone by. I'll stress that again. N represents the number of pay periods that have gone by. In this case, pay periods are every 6 months. So the total time, or the time for investment, is 15.78 times 6 months, or 94.68 months. Now, might be a little bit more helpful to talk about that in terms of years. So if I divide by 12, or 7.89 years. However, Luis is not getting things every 0.89 years. So we've got to round to the nearest part of a year. So I'm going to have to go up. So that would tell me that in 8 years, Luis will have more than $18,000. Okay. I'm going to leave it at that for now. Any questions, you know where to send them to. Now, since we're still figuring things out, I can't really technically assign work, but if anybody wants to try a few things out to practice with this a little bit, you can work on some of the following. Questions 1 to 10, 13, 15, and 18 from pages 55 to 57 of your textbook. All right, everybody, I think that's going to be it for me. Hope everybody's staying safe and as well. Good luck out there.